Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, let us move to the next question, question number 33 of JEE Advanced Physics paper 2015. So let us solve question number 33. So students, let us solve this question. Number 33 says that a spherical body of radius r consists of a fluid of constant density. So this is a body, spherical body, which has center suppose here, and the radius is r is the radius, and it is filled with some fluid of constant density. Suppose the density is rho and is in equilibrium under its own weight. So when says that one weight means that the weight of that is balanced by let us first read the question. Under its one weight, if PR is the pressure at a distance r less than r, then correct option is or r. That means first of all, this is suppose center O at a distance r, which is less than r, obviously, because this is the radius of the sphere. We consider one such spherical section. This is a spherical section. So at a distance r, I consider element at a distance r, I consider one element of mass dm. That dm is like this. So from this is r and this is dr. This one is dr. So this distance is dr. And this distance is r. Okay. Now this element that I have considered here, this elementary section, whose I could say that the thickness because this is a hollow sphere, its thickness is dr. It's a hollow sphere whose thickness is dr, and whatever it's the pressure you define, the pressure is force per area. Pressure is, so because of this small element that I've considered, the pressure here is the force upon the area. This is supported by the forces from here. The pressure on this whole, because this is in equilibrium, this whole element is under is balanced, because the weight is balanced by the pressure here. The weight of this is balanced by this pressure here. So the weight is balanced by the force due to this pressure. So this pressure is, suppose this is the pressure is whatever is the pressure, and that into the area, that is the force, and that is equal to the weight of this element. So this is for only this element under consideration, but you have to find pressure due to the whole of this. As you change the element, the r will change, and obviously the pressure will change. So this pressure is a variable one. So you have to go for integration, and the first element I will choose here at any point r to r. It says that is a function of r. So I will choose from r to the capital R, any r. Depending on r is 0, I can put r is 0 also. But as a function of r, I have to integrate it from r to r. So if I integrate this from r to capital R, then I will get the pressure as a function of r. this pressure as a function of R is dF. What is dF? It is the weight of the liquid, this portion of the fluid, that is G by Newton's law of gravitation. This is G. M is this mass. dm is the mass of the element upon r square, and this area is 4 pi r square. This force is distributed in this area 4 pi r square. Integration from r to r. Now the pressure comes out to be G. Here it is M. The small m can be written as the density of the fluid into the volume. Volume is 4 by 3 pi r cube, because r is the radius, so volume will be this. And what is the mass dm? Dm can be represented as the density is same into the volume. The volume is 4 pi r square into dr. This is the volume. Okay, so I will write in terms of this. So this mass of the element is density into volume of the element, because this is a hollow sphere. You can see this is the hollow sphere. This is the element. So only this portion mass is dm. So density into volume of this is 4 pi r square into dr is the volume of that. So I will substitute here rho 4 by 3 pi r cube into dm, that is rho 4 pi r square dr. Okay, so from here this is, and divide by r square 4 pi r square, that is 4 pi r4, r is to 4. You have to integrate this from r to r. 4 pi will cancel. R4, here it is R5, so only R will be left, and rho square. So I write 4 pi will come out, rho square will come out, G will come out, and one R is there, so R dr. Here R4 cancels, so this is the value R to R. Now this will give 4 pi G rho square, and this is r square by 2, so it is r square by 2 comes out, r square minus r square. This is the value of P as a function of R. Okay, so once we have got the value of P as a function of R, we will go for all the options. Now check all the options, which one is correct. So let me write the function P of R. We have got as 2 pi G rho square, but because that 2 will cancel out, and r square minus r square. Option number 1. The option number 1 says that P of r equals to 0 is 0. True or false? So if I put r equals to 0 over here, then here also I have to put 0. If I put 0, this will not be 0. So therefore, this is not correct. It is a wrong statement. Second option, so first one is wrong because this is not 0. B1 or option number 2, that is, if you see the option number 2, it says that R you put 3R by 4 and R you put 2R by 3, then divide it and what you are getting. So the question is P of R equals to 3R by 4 divided by P of R equals to 2R by 3, which is 63 upon 80. You have to check this whether it is 63 upon 80 or not. Now what is there? We have our values formula. You have to just substitute this value. So R is this. So first I will find this one, or I will go directly with this. P of this one 3R by 4 divided by P of 2R by 3. If I put this here, the ratio, this will cancel out, only this ratio will be there. So it is R square minus R square. The small r is this one, squaring it, it is 9R square divided by 16 divided by 2R by 3 I have to put here. So it is R square minus 4R square divided by 9. Squaring it, it will be 9. Now taking R square common, it will cancel out. R square will cancel out. This is 16 minus 9, that is 7. 7 divided by 16 divided by, this is 9 minus 4, that is 5. 5 divided by 9. This gives us 7 into 9 divided by 5 into 16. This is 63 and this is 16 5 is 80. This is 80. That means the option that is given 63 upon 80, we are also getting 63 upon 80. So B is correct. Okay. So first of all, we will say that this B is correct, or the option number 2 is correct. Then we have to check for the option number 3, that R is this and R is this, and see what we are getting. So let us put that. P of R we are getting is proportional to R square minus R square. So option number 3 says, you substitute 3R by 5 divided by pressure of 2R by 5. It says that it should be 16 upon 21. You have to check it whether this is correct or not correct. So this upon this, P of 3R over 5 divided by P of 2R upon 5 equals to, putting this value here, this is R square minus square of this 9 upon 25. So it is 9R square upon 25 divided by R square minus this R square is 2R by 5 square is 4R square by 25. So if I solve this, then this is 25 minus 9, it is 16 R square. So it will be 16 R square divided by 25, and here it is 25 minus 4, that is 21 R square divided by 25. This means 25 will cancel out, R square will cancel out, so it becomes 16 upon 21, which is correct. So the option that is 16 upon 21 is also correct. So therefore this one is correct. Then you have to put this value. Fourth option you have to check. The fourth option is that it says that P of R, which is R by 2, you have to substitute, and P of R, which is R by 3, you have to substitute, and that gives us 20 by 27. We have to check this whether it is 20 by 27 or not. So P of R by 2 divided by P of R by 3 is proportional to, this is proportional to R square minus R square as usual. So it is R square minus R square, square of this is R square by 4 divided by, similarly you put these values, and then R square can be cancelled with taking common. R square cancelling, this is 3 by 4 and this is 5 by 9 minus 1, that is 8 by 9. This is 4 minus 1, 3 by 4, this is 9 minus 1, that is 8 by 4, 8 by 9. So this comes out to be 3 into 9 divided by 8 into 4. So that is 27 divided by 32. 27 divided by 32. So therefore this is not matching. This is 20 by 27, but we are getting 27 by 32. So therefore this is not correct. So option number 4 is also not correct, and 1 is not correct. So 2 and 3 are the only correct answer to this question. Okay. So basically what we've done is you have to consider the element, then find the force per area. Area is this element is a sphere, hollow sphere, but then force is the weight of uh, the weight of this or the force is because of the gravitational force, that is this mass will exert whatever force. This mass will exert a force of gmm upon r square, because this is addition that. This is the force that is exerting the inner mass will exert on the liquid. So integrating that, you will get the answer. Okay, thank you.